atomic properties. So we will learn the effective nuclear charge, atomic radius, ionization energy, electron affinity, electronegativity, metallic property, and the exceptions to the periodic. Gina? G. Okay, let's go. Guys, recall from your bridging course that you discussed periodic table. Now, we will explore in depth the periodic table, the periodic trends, and how it explains the properties of bonds. So the main basis of periodic trends is the effective nuclear charge. So the nucleus, yung nasa gitna, it attracts electrons through electrostatic force. Okay? Now the inner electrons into the loob feel the stronger pull, while outer or valence electrons experience weaker attraction to the nucleus. Now bakit? The weaker attraction is because the inner electrons cancel and shield some of the nuclear charge being received by the valence electrons. Okay? Because of this, the effective nuclear charge on ZEF or the ZEF measures this net attraction and is used as a basis in explaining periodic trends. So guys, basically pabida-bida kasi yung mga inner electrons na yan. Okay? Sinishield nila yung attraction ng nucleus sa outer electrons. Okay? To know more about effective nuclear charge, let's watch this video. Okay.
Today, we're going to learn all about nuclear charge, shielding effect, and effective nuclear charge because we will be using these concepts to explain the trends and variations in atomic radius, first ionization energies across a period and down a group, and the successive ionization energies, so do stay tuned for my upcoming videos. Firstly, let's talk about nuclear charge. As the name suggests, nuclear charge refers to the positive charge of the nucleus because of the positively charged protons that's inside of it. The positively charged nucleus will attract the negatively charged valence electron towards itself, which causes a contractionary effect on the atom. Hence, the strength of the nuclear charge depends on the number of protons present in an element. So when the number of protons in an element increases, the nuclear charge increases, and this in turn causes the electrostatic force of attraction between the nucleus and the valence electrons to increase, thereby making the atomic radius smaller. On the other hand, the shielding effect in an atom has an expansionary effect which causes the atomic radius to become bigger. This happens because the electrons in the inner shells repel the electrons in the outer shells, hence forming a shielding effect which prevents them from experiencing the full effect of the actual nuclear charge. Both the shielding effect and the nuclear charge are occurring at the same time, and the combined expansionary and contractionary effect is what we call the effective nuclear charge, which is given by the formula effective nuclear charge equals to nuclear charge minus the shielding effect. So if the nuclear charge is greater than the shielding effect, the effective nuclear charge increases and there will be a net inward force of attraction between the nucleus and valence electron as it is stronger than the shielding effect between the electron shells.
Okay, now we know the concept of effective nuclear charge. Now, let's discuss the trend for effective nuclear charge. Down a group, the effective nuclear charge almost constant lang. We would expect, diba, na may increased nuclear charge down a group kasi mas marami yung number of protons, diba? Kasi nag-increase yung atomic number. However, this is not the case kasi na-offset din ito ng more inner electrons sa shells. Okay, again, mas dumadami din kasi yung inner electrons as you go down a group. This is why the effective nuclear charge cannot explain the periodic trend down a group. Across a period, the effective nuclear charge increases because mas maraming protons in the nucleus that increases the nuclear charge and its attraction to the outer electrons. Now we know that there is more protons across a period kasi increasing ang atomic number. We can quantify the effective nuclear charge through this equation, where the effective nuclear charge is equal to the atomic number Z minus the shielding constant S. Now, the shielding constant represents how the inner electrons cancel or reduce the attraction between the nucleus and the electron of interest. So it accounts the shielding effect, sabi nga kanina, right? So a higher effective nuclear charge means a stronger attraction between the nucleus and the electron. Now, the Slater's rules are used to determine the value of the shielding constant. It is calculated based on the proximity of the inner electrons to the electron of interest. Okay? So, kunwari, meron tayong electron of interest dito. Dito. Kita niyo yung red na yan. Ayan. Yan yung electron of interest nyo. Now, electrons that are closer to the nucleus, kumari dito, may mga electrons ka dyan, contribute more significantly to shielding constant. As you can see, 1 ang contribution nila. While those na mas malayo sa nucleus, or those on the same shell as the electron of interest, kumari dito na shell, and -1 shell, okay, they contribute less to the shielding constant, 0.85. Okay? Don't worry guys, ulit-ulit pa kayo. We will do this step by step. So, how do we compute for the shielding constant S? Step 1, we group the electrons based on N or increasing energy. So guys, recall your electron configuration lesson. Okay, so we just group them based on N. 1s, 2s2p, 3s3p, 3d, ibang group yan guys ha. 4s4p, 4d, 4f, 5s5p, 5d, and 5f. So remember nyo lang guys, ang S and P groupmates sila lagi. Pero yung D, yung F, naka-individual sila. Okay, ayan. So step 2, compute the shielding constant based on the sum of electrons per group multiplied by their contributions. So yung contributions ito is this, given by this table. So the electrons in the higher orbitals and the electron of interest are not included. Okay, for example guys, yung electron of interest no, okay, yung hinihingi sa isang problem belongs to the 1s group. Okay? Then ang contribution ng other electron na sa same 1s group na yan is 0.30. Okay? What if naman ma'am, nasa NSNP group siya, yung electron of interest. Now yung other electrons na nasa same group na yan, 0.35 ang contribution. And if nasa ND or NF group naman ang electron of interest, 0.35 ang contribution nila. Okay guys? I hope that's clear. Okay? So don't worry kasi isa-isahin na natin sa ating sample problems. So first sample problem, calculate the effective nuclear charge of a 1s electron in neodymium atom. First, we determine the atomic number of neodymium, which is equal to 60. Usually guys, yung step 1 dito, hanapin talaga natin yung full electron configuration. Pero since 1s lang naman yung hinahanap guys, 1s, yung electron of interest, so hindi natin kailangan yung other electrons na outside of the electron of interest. Tandaan nyo pa guys ha, yung kailangan nyo lang for the shielding constant is yung other electrons na sa same group ng electron of interest and other electrons na mas malapit sa nucleus. Okay? Gets ba guys? That's why, for step 1, 1s2 lang yung nakalagay. Okay? Again, walang effect sa shielding constant yung electrons outside of the electron of interest. So here, we have one electron of interest, right? Dalawa, yung 1s electrons natin. So yung other electron, okay, has a contribution to the shielding constant. Since 1s group, yung other electron, okay, na nasa same group, 0.30 yung contribution ng electron na yun. So let's calculate the shielding constant. S is equal to the 1 electron from the same group as the election of interest times 0.30, yung contribution, is equal to 0.30. Calculating for the effective nuclear charge, Zef is equal to Z minus S. So 60 minus 0.30 is equal to 59.70. So that's your effective nuclear charge. Diba guys, napakalaki ng Zef niya. This is expected from an electron, a 1s electron, that is very near to the nucleus. Kasi syempre, 1s siya ang pinakamalapit sa nucleus, right? Okay. Sana get so far, very easy pa yan, diba? Now let's move on to number 2. Calculate the effective nuclear charge of a 5s electron in strontium atom. So this is found in your memos. So first we find the atomic number, okay? So the atomic number is equal to 38. Tingnan lang sa periodic table. Next, you write the full electron configuration of strontium. Full ha? Okay, so that's this. Okay? Now, step 1. Group nyo muna yung electron configuration based on increasing energy. So 1s2, groupmate sila. 2s2p, groupmate sila. 3s3p, groupmate sila. 3p, groupmate, individual. 4s4p, groupmate. 5s2. Kasi siya lang naman talaga mag-isa. Wala ka namang 5p dito, di ba? Okay, so your electron of interest ulit is a 5s electron. Isang electron from the 5s orbital. So, yung other electron in the 5s orbital contributes to the shielding constant. So, it's an electron in the same group. Now, may effect din sa shielding constant ang electrons in n-1 group. Since n is equal to 5, then n-1 is equal to 4. So 4s2, 4p6, sila yung electrons in n-1 group. And the rest of the electrons here, sila naman yung electrons in n-2 or lower groups. Guys, itong black na nakabox, itong blue na nakabox, and itong red na nakabox, may iba silang contributions to the shielding constant. So, calculating for the shielding constant, guys, refer na lang kayo sa table, okay? So, the shielding constant is equal to 1 times 0.35, kasi 1 electron from the same group ang nagko-contribute sa shielding constant, plus 8 times 0.85, 6 plus 2, 8 plus times 0.85, ito yung contribution sa for n-1 group. And 28 electrons, so 2, 4, 10, 12, 18, 28 electrons in n-2 or lower groups times 1, that's equal to 35.50. That's your shielding constant. Yeah, for your reference, guys, okay? Tama, diba? 0.35 for the same group. Here, 0.85 for n-1 group. And 1, yung contribution ng electrons in n-2 or lower groups. Okay? So the value of the effective nuclear charge is equal to atomic number minus shielding constant is equal to 38 minus 35.15 is equal to 2.85. The effective nuclear charge of a 5s electron in strontium atom is 2.85. What can you observe? The electron in the 5s atom has a low effective nuclear charge. 2.85 lang kasi yung electron, malayo na siya sa protons in the nucleus. Nasa n is equal to 5 energy level na yung electron diba? Also, napakaraming electrons below n is equal to 5 ang nag-shield ng attraction ng 5s electron sa nucleus. Okay? Napakarami ng electrons sa n is equal to 4, napakarami ng electrons sa n is equal to 3 and lower groups na nagko-contribute sa shielding effect. Kaya, mababa ang ating effective nuclear charge. Okay? Okay, last, calculate the effective nuclear charge of a 3d electron in iron atom. So, the atomic number for iron is equal to 26. And here is the electron configuration. Okay? So guys, dapat marunong na tayo dyan, okay? Step 1, we group it based on increasing n. Yeah. So guys, ating electron of interest is, yes, 3D, nandito. Okay? So meaning guys, ito, X na yan ha, wala siyang effect sa shielding. Right? Kasi outside siya ng electron of interest. Okay? The inner electrons will affect the shielding constant. Now, isang electron lang naman ang iniinteresan natin dito kay 3D. So yung 5 electrons na natitira sa 3D orbital contributes to the shielding constant. Then, all of these guys, yung 1s2, 2s2, 2p6, 3s2, 3p6, they are considered as electrons in n-2 or lower groups. Okay? And they have a different contribution in the shielding constant. Ma'am, bakit? Parang hindi naman yun nakalagay sa table. This is because for a 3D electron, guys, okay, 3s and 3p orbitals are considered as inner to 3D. Kaya, 1 namatik ang contribution ng electrons ng 3s and 3p orbitals. Okay? Tandaan nyo to guys ha, if ang electron of interest nyo ay nasa nd orbital, gaya ng 3D, the electrons in the ns and np orbital contribute 1 each to the shielding. Okay? So now, let's calculate for the shielding constant S. So, we have 5 electrons in the same group. 5 times 0.35, yung contribution nila, refer to your table, plus 18 electrons. So 6 plus 2, plus 6 plus 2, plus 2. That's 18 electrons times 1. Lahat ang contribution nila. Okay? 1 ang contribution nila sa shielding constant. That's equal to 19.75. Calculating for the effective nuclear charge is equal to atomic number minus shielding constant. 1 to 6 minus 19.75 is equal to 6.25. Okay? Guys, I hope that's clear. Okay. So now let's move on to the next periodic trend. Watch this video first on atomic radius.
Atomic radius is a measure of the typical distance from the center of the nucleus to the boundary of the surrounding cloud of electrons. It's affected by the number of protons and electrons that make up an atom. Both change in predictable ways throughout the periodic table. Let's take a look at group trends first. As you travel down a group, you are adding electrons to energy levels that are farther away from the nucleus. All elements in group 1 have one valence electron, but different electron configurations based on their period. Hydrogen is in the first period, which means it has 1 electron shell. Its atomic number is 1, which means a neutral atom of hydrogen has 1 electron. Lithium is in period 2, which means it has 2 electron shells. Its atomic number is 3, so a neutral lithium ions configuration looks like this. Sodium has 3 electron shells. Its atomic number is 11, so a neutral atom has 11 electrons. As you continue down the group, the atomic radius continues to increase due to the increase in electron shells. Now let's examine trends across periods. As you are traveling across a period from left to right, the atomic radius decreases due to the effective nuclear charge and electron shielding. We're going to compare lithium and beryllium to gain a better understanding of how these processes affect atomic radius. Lithium has an atomic number of 3. This means a neutral atom of lithium will have 3 protons and 3 electrons. There are 2 electrons in the inner shell and 1 in the outer shell. The positively charged protons pull in the negatively charged electrons. At the same time, the inner shell electrons repel the outer shell electrons because they have the same charge. This is called electron shielding. When we move from lithium to beryllium, we gain 1 proton and 1 electron. It's important to note that outer shell electrons do not shield the other electrons. That means that beryllium has the same number of electrons shielding as lithium does. However, beryllium does have a higher effective nuclear charge because of that additional proton. This increased positive charge in the nucleus causes electrons to be pulled in more strongly, resulting in a smaller atomic radius. So as you continue to travel across the period, the atomic radius continues to decrease. As you can see from the examples provided, the atomic radii change in predictable ways throughout the periodic table.
Hey guys, I hope here na-learn ninyo ang concept behind atomic radius. Now, these are the 3 types of atomic radius, depending on the type of bonding. The metallic radius is half the distance between the nuclei of adjacent atoms in a metal lattice, for example, sodium metal, while covalent radius is half the distance between the nuclei in a molecule consisting of 2 identical atoms, such as chlorine. These are 2 nonmetals, right? Lastly, the ionic radius is half the distance between neighboring ions in an ionic compound, for example, sodium ion and chloride. Thus, atomic size is measured through the internuclear distance between atoms, okay? Because the radius of just one isolated atom cannot be directly measured. Okay? Now, let's go to the atomic radius trend. Down the group, increasing due to electrons in higher levels or increasing n. In other words, the valence electrons, mas malayo sila from the nucleus as n increases. This is also because the more inner electrons down the group are shielding the outer valence electrons. Kaya, mas loosely held yung valence electrons. Okay? Na-expand nila ang electron cloud. Then, decreasing naman across a period because electrons are being added in the same shell or n. At the same time, protons na add din sa nucleus across a period, diba? Making it more positively charged. Guys, yung effect of increasing the proton number, mas malaki siya than increasing the number of electrons. Kaya, mas nagkakaroon ng mas malakas na nuclear charge that strongly attracts the electrons more and pulls the electron cloud closer kaya lumiliit yung atomic radius. Okay? Now, ionic radius trends are a different case because it is influenced by ion charge. Okay? So, the cation ions, guys, dito sa baba, are smaller than their neutral atoms because losing electrons reduces electron repulsion. Okay? So, pag nagtanggal ka ng isang electron, it reduces the repulsion between the electrons. Okay? Kaya mas kayang i-attract ng nuclear charge ang electrons closer sa kanya. Okay? For example, for the sodium cation, mas maliit siya than the sodium na neutral lang. In contrast, anions are larger than their neutral atoms because of the increased repulsion between the added electrons in the valence orbital and the inner electrons, causing the electron cloud to expand. Okay guys, since nagdagdag ka ng electron kay fluorine, merong increased repulsion between the valence electrons and the inner electrons, kaya nag-e-expand ang electron cloud. That's why fluoride an ion is bigger than fluorine. Okay? Sample problem. Okay guys, pause the video and try niyong sagutin. Okay, let's answer. Arrange iodine, bromide ion, bromine, and iodide ion in order of increasing atomic size. Ayan ang ating sagot, guys. Ayan, yan ba sagot niyo? I hope so. So, si iodine and bromine, they are in the same group, right? Halogens. From the trend, we know that iodine is larger since atomic radius increases down group. So, alam na natin yan, iodine is bigger than bromine. Now, let's compare bromine versus bromide. Since an ion bromide is bigger than its parent atom bromine, bromide is larger than bromine. Okay, again, ions are larger than their parent atoms. Now, iodine is still larger than bromide because the number of electron shells in iodine, mas marami pa rin kaysa sa bromine, right? Mas malaki pa rin yung N niya. Okay, dahil dyan, si iodide ang largest among the given species. Okay, guys, reminder, always remember that when the question asks increasing, it means from smallest to largest. Okay, just in case nalilito pa kayo. Again, from smallest to largest, increasing. Okay, now let's go to our next trend, ionization energy, which is the minimum energy required to remove an electron from a gaseous atom in its ground state. The removing of the electron from an atom is endothermic. Okay, thus, it absorbs energy. This is why the ionization energy values are positive. Okay, kita niyo ba sa figure na ito? So, nag-remove ka ng electron, and that is an endothermic process. So the figure shows the successive ionization of an aluminum atom. Habang mas nagiging positive yung charge ng aluminum, di ba? Al+, Al2+, Al3+, mas onti yung electrons, di ba? Kasi nababawasan ng electrons every time. Thus, the inner electrons are more tightly held by the nucleus. Dahil dito, mas nagiging mahirap magtanggal ng isa pang electron. Thus, greater ionization energy is needed to remove an electron. So, the ionization of aluminum atom to form the aluminum ion, okay, that refers to the first ionization energy. While the successive reactions, like itong second and ang third, shows the second ionization energy and the third ionization energy. So guys, the value for the first ionization energy is lower than the second and the third IE values. Dahil kay dito, sa aluminum atom natin, mas madali pang magtanggal ng electron kesa dito kay Al2+. Kay Al2+, mas tightly held yung inner electrons ng nucleus. Kaya mas mahirap magtanggal ng electrons kay Al2+. So let's go to the trend. Down the group, ionization energy decreases because of increasing energy level. Thus, mas madaling magtanggal ng electron down the group. Across a period, ionization energy increases as the effective nuclear charge increases, since the greater attraction between the positive charge in the nucleus and the electrons makes it harder na magtanggal ng valence electron. Okay? Sample problem. Okay, pause this video first and try to answer. Okay, let's answer. Arrange silicon, carbon, neon, and lithium in order of increasing ionization energy. Guys, again, down the group, ionization energy decreases. Across a period, ionization energy increases. And this is our periodic table. Okay, tingnan natin. So si lithium, siya ang nasa leftmost na periodic table, then carbon, then silicon, then neon. Okay, so ano kaya answer, guys? Yes, it's this. In order of increasing energy, lithium, silicon, carbon, then neon ang may pinakamataas na ionization energy based on this trend. Okay? Tama naman guys, diba? Sagot nyo? Kasi nasa leftmost, si lithium siya ang may pinakamaliit na effective nuclear charge. So, siya yung may pinakamaliit na ionization energy. Followed by silicon. Okay? mas mababa ang ionization energy niya than carbon because down the group, IE decreases. Okay. Then, si neon naman ang may pinaka-malaking ionization energy because of its effective nuclear charge. Siya may pinaka-malaking effective nuclear charge. Okay? Also guys, take note, neon is a noble gas. A noble gas is very stable. Kaya, sobrang hirap nang magtanggal pa ng electron sa isang stable atom like a noble gas. Okay? Let's move on to electron affinity. So it refers to the energy change that occurs when an electron is added to a gaseous atom. So adding an electron is an exothermic process. So pag nag-add ka ng electron sa atom, it releases energy. Tandaan guys, okay? Guys, recall kapag exothermic, negative ang value natin for energy. So the more negative the electron affinity value, the greater an atom's affinity for electrons. Okay? Now, if the value for EA or electron affinity is positive or less negative, then that means the atom has lower affinity for electrons. So for example, when an electron is added to a gaseous atom chlorine, energy is released to form the fluoride anion. And the value of its electron affinity is negative. So here's the trend. Same lang siya with ionization energy. So down the group, electron affinity or EA decreases or becomes more positive or less negative because of increasing N, where the electrons are being added much farther from the nucleus. So sobrang layo ng incoming electron guys na idadagdag mo, hindi na siya napapansin o na-attract ng positive charge ng nucleus. Kawawa naman. Kaya nga sabi nila, di ba, lagi ka nang lumapit sa crush mo para ma-attract siya sa'yo. Okay, moving on. Across a period, EA increases naman or becomes more negative due to the increasing effective nuclear charge, which means across a period, may stronger nuclear charge ka that can more easily attract another electron to an atom. Guys, pag sinabi, for example, fluorine has a high electron affinity, meaning nun, it has the greatest amount of energy released to add an electron to its atom. Okay? So when you say sodium has a low EA, meaning nun, it has a low amount of energy released or great amount of energy is required para mag-add ka ng electron kay sodium. Okay? So now, next trend. Electronegativity can be viewed as this tug-of-war of atoms. So here's at us, two hydrogen atoms happily and equally share electrons because they are similar atoms that have the same electronegativity. However, dito ba, fluorine, yung purple, is more electronegative compared to hydrogen. Kaya, mas kaya niyang mag-attract ng electrons more toward itself. Okay? Ganon ang concept ng electronegativity. So, electronegativity describes the ability of an atom to attract electrons. Specifically, En explains the ability of an atom to attract electrons from another atom in order to form a chemical bond. So, in the bond, the more electronegative atom gains a partial negative charge, itong blue dito, and draws electron density papunta sa kanya. While the less electronegative atom, itong red, becomes partially positive. Guys, don't confuse electronegativity with EA, okay? Again, electronegativity is a relative measure that requires the comparison of two atoms. Okay? Sa electron affinity, iba rin yan guys kasi may energy na release pag nagdadagdag ka ng electron sa isang atom. Okay? Now, here's the trend for electronegativity. As the atomic number increases, okay? Sorry, mali pala. So down the group, electronegativity decreases, right? Since the farther outer electrons are weakly attracted to the nuclear charge. Okay? Then across a period, ito na yun, electronegativity increases. Since the increase in the number of protons and effective nuclear charge across a period pulls the electrons more strongly. Right? So, fluorine, siya naman yung most electronegative element based on the periodic table, right? Okay. Guys, tandaan to, okay? Now, for more info on electronegativity, kindly watch this video.
Recall that when atoms form covalent bonds, they do not always share their electrons equally. This is because atoms differ in their electronegativity, or their ability to attract electrons. If the electronegativity for an atom is high, then it strongly attracts electrons. If the electronegativity for an atom is low, it does not pull at the electrons as much. We can look at this portion of the periodic table to help visualize the electronegativity of the first several elements. Notice the gradient of light blue to dark blue that indicates the increasing electronegativity of the elements. Look closely at the symbols for carbon and hydrogen. Notice that they have similar shading and close electronegativity values. This means that when carbon and hydrogen are bonded together, as shown in this methane molecule, both atoms have a similar ability to attract electrons. Neither element pulls more than the other. This type of covalent bond is called a non-polar bond, since the electrons are more or less equally shared between the two atoms. The electronegativities of hydrogen and oxygen are very different. As you can see from the chart, the electronegativity of oxygen is higher than the electronegativity of hydrogen. Because of this, when oxygen and hydrogen are bonded together, as shown in this water molecule, oxygen pulls at the electrons more than hydrogen does. This causes the covalent bond between the oxygen and hydrogen atoms to become polar. In a polar covalent bond, one of the atoms, in this case oxygen, has a slightly negative charge since it has a greater affinity for electrons, while the other atom, hydrogen, has a slightly positive charge because its electrons are spending more time around the oxygen atom.
Okay, now you know the deep concept behind electronegativity. Guys, that will be helpful on our lesson on chemical bond. So guys, tandaan niyo yan, okay? Now, let's proceed to our last trend, metallic property. So metals, which are located on the left side of the periodic table, typically lose electrons to form cations. Non-metals, found on the right side of the periodic table, generally regains electron from anions. So that is an example. Okay, sodium atom loses an electron to form a sodium cation, while chlorine gains an electron, okay, to form the chloride anion. So this is just a bit of a mnemonic. Metals form Ka plus ions, cations. Non-metals form anions, where N here means negative. Okay, again, metals form Ka plus ions, non-metals form anions. So the trend is similar to atomic radius. Down a group, metallic property increases because the outer electrons become farther from the nucleus, so mas madaling matanggal ang electron. Across a period, atoms are less metallic because as the effective nuclear charge increases, there is greater attraction between the nucleus and the electrons. Plus, mas mahirap mag-lose ng electrons. It also becomes easier to gain electrons due to the increasing effective nuclear charge. In relation to this, guys, the reactivity of a metal has a same trend. So the reactivity of a metal decreases across a period then, since metals are more reactive when they lose electrons. Okay, dahil kasi sa increasing effective nuclear charge, guys, it becomes more difficult for the metal to lose an electron. While reactivity of a metal increases down a group, since metals with greater N, okay, tend to lose electrons easier. Yung electrons sa higher energy level and mas malayo sa nucleus ay madaling mawala or matanggal. Okay? Okay, last sample problem. Compare the metallic character of sodium, chlorine, aluminum, sulfur, and cesium. Let's answer together. Again, guys, down a group, metallic character increases. Across a period, metallic character decreases. So, dito pa lang guys, makikita natin si cesium yung pinaka-metallic. Okay? Followed by sodium. Then, aluminum, then sulfur, then chlorine. So, cesium is the most metallic. Followed by sodium, aluminum, sulfur, and chlorine is the least metallic. Yan. Tapos na tayo sa ating atomic properties, guys. Congrats, diba? Kayang-kaya, madali lang, okay? Basta tandaan nyo lang ang mnemonic nito for our periodic trends. So, si Maria. Sino kaya si Maria na yan? So, si CMAR, sa red muna tayo, stands for C, tendency to form cations, L, metallic property, A, atomic radius, and then R, reactivity. Where, across a period, their trend decreases, while down a group, their trend increases. Si IIA naman, IA, stands for I, ionization energy, E, electron affinity, E, electronegativity, and A, tendency to form anions. Where across a period, their trend increases, and down a group, the trend decreases. Okay, tandaan niyo yan guys, okay? Si Maria. Okay, si CMAR, okay? Iba ang trend sa trend ni II. Okay? Now, there are many atoms which do not exactly follow the periodic trends. So one cause of this is the lanthanide contraction. It is a decrease in atomic size from left to right of the lanthanide metal. So these are your lanthanides. Now, the additional electrons ng lanthanide metals are from the f orbital electrons of the lanthanides. Now, nalala niyo sabi ko last time, yung f orbital, big siya, yung shape niya, very spread out. Wala siyang definite shape. Hence, electrons from the f orbital poorly shields the outermost electrons. Okay, from attraction with the nucleus. Okay, again, may poor shielding effect yung inner f orbital electrons ng lanthanides. Okay, kaya may stronger attraction between the nucleus, okay, and the outermost electrons or the valence electrons. Dahil dito, mas lumiliit ang atomic radii ng 6th period elements. Okay, and dahil dyan, ang result ng lanthanide contraction ay same or similar ang atomic radii ng period 5 and period 6 elements. Okay, guys, I hope that's yan. So now, we proceed to our exceptions in the periodic trends. Okay, so we will summarize each trend depending on their exception. So let's start with the exception to the periodic trends, starting with atomic radius. So first exception, guys, mas maliit ang gallium than aluminum. It is due to the poor shielding of the d electrons from gallium. Okay. So from the general trend, we expect that gallium is bigger than aluminum because the atomic radius is increasing down group. However, guys, that is not the case because si gallium, guys, meron siyang d orbital electrons, right? Based on its electron configuration, which is argon, 4s2, 3d10, 4p. Now, the d orbital is more complex compared to the s and p orbitals, which aluminum has, right? Now, because it's so complex, the electrons in the d orbital have poor shielding effects. Okay? They can only poorly shield the nuclear charge from the outermost electrons. Kaya, may stronger attraction between the protons in the nucleus of gallium and the outermost electrons of gallium. That's why liliit pa si gallium compared to aluminum. Okay? Next trend. We have, okay, balik ko lang. So, mas malaki ang atomic radius ng noble gases. And that is because of their fully filled valence orbital, which is Me6. And it's drawn like this, guys. So here, there are very strong electron-electron repulsions, and that's why the electron cloud of the noble gases will expand. Hence, noble gases, for example, neon, and if may katabi siyang halogen such as fluorine, okay, neon is expected to be bigger than fluorine. Okay, so it does not follow the atomic radius trend. Okay. Third exception, so there is an irregular trend for the atomic radius of transition metals. Now the transition metals, if you can recall from our periodic table here, okay, the transition metals have d orbital electrons. Like I said kanina, d orbitals are more complex. Their behavior is more complex compared to the s and p orbitals. That's why we would expect that the transition metals will not follow the general atomic radius trend system. Okay. And lastly, the atomic radius of period 5 and period 6 elements are equal, and that is because of the lanthanide contraction. So this is period 5, guys, and this is period 6, which also includes the lanthanides. Again, from the lanthanide contraction, magliliit ang 6 period elements. Okay. At dahil dyan, magiging similar ang size ng period 5 and period 6 elements. Okay. I hope that's clear. Now, let's move on to the exceptions for ionization energy. So we have 3. First is lower ionization energy for group 16 elements than group 15 elements. Okay, sorry about this ha. Please correct this sa inyong manual. Again, dapat yung group 16 ang may lower ionization energy. Okay, not group 15. So, lower ionization energy for group 16 means that mas madaling magtanggal ng electron in group 16 elements compared to group 15 elements. So let's compare nitrogen from group 15 and oxygen from group 16. Nitrogen has an electron configuration of helium 2s2 2p3. Oxygen naman, ito, 2s2 2p4. And when we draw it, let's compare. For nitrogen, it's 1, 2, 3. For oxygen, it's 1, 2, 3, 4. As you can see here, guys, si nitrogen has a stable half-filled valence orbital. Okay? So, mahirap nang magtanggal ng electron sa isang valence orbital gaya ni nitrogen and other group 15 elements. Meanwhile, mas madali magtanggal ng electron dito kay oxygen because stronger ang electron-to-electron repulsions niya. Diba? Kasi may paired electron to dito. mas gugustuhin natin matanggal ang electron dito for it to be more stable and be half-filled. Okay? That's why lower ang ionization energy for group 16 than group 15 elements. Next, so lower ionization energy for boron than beryllium. Let's compare first the electron configuration. So for boron, it's He, 2s2, 2p1. When I draw that, okay, sorry, ito pala. Tapos, 2p ito. For beryllium naman, it's just 2s2. So yan ta. So guys, mas madaling tanggalin yung electron dito na nag-iisa kay 2p. Right? Mas madali yan tanggalin compared dito kay beryllium. Bakit? Because when you remove this electron from the 2p orbital of the boron atom, the boron will become more stable kasi magiging fully filled stable na ang valence shell niya. Next, for beryllium naman, it's already stable in itself kasi yung valence electron orbital niya is 2s2 that is fully filled, that is stable. Mahirap na magtanggal ng electron dyan. Okay? Therefore, there is lower ionization energy required to remove an electron for boron than beryllium. Okay? So that is just the same concept as the third exception. So, lower ionization energy for group 13 elements such as boron dahil meron silang additional what? Electron sa kanilang 2p orbital na mas madaling tanggalin guys kasi mas malayo to sa nucleus compared to the tightly held s orbital electrons of group 2 elements. Okay? As you can see here, mahirap na magtanggal dito again. Okay? Kasi tightly held na siya and lower in energy. Okay? And of course, it is fully filled. I hope that's clear. So, let's proceed. Next, these are the exceptions to periodic trends for electron affinity. First exception guys. So, higher electron affinity of group 1 than group 2 elements. So when we say higher electron affinity, meaning yan, more negative electron affinity. And meaning yan, more energy is being released when adding an electron to an atom. For group 1, ang kanyang valence orbital diba is ns1. For group 2 naman, it's ns2. Right? So let's say we have an s orbital here, with s orbital here. For group 1, diba isa lang yan. For group 2, dalawang electrons. Now let's say we have to add 1 electron to each of them. Pag nag-add ako ng 1 electron kay group 1, magiging fully filled and stable siya. Pag nag-add ako ng isang electron kay group 2, I would have to make a new orbital to add the electron. Now, greater energy is being released when adding an electron for group 1 elements. Kasi gusto niyang mag-accept ng electron para mas maging stable siya, para maging fully filled and complete yung valence orbital niya. Okay? Whereas, for the group 2 and S2 elements, okay, the group elements will release less energy when you add an electron. Why? Because guys, pag gumawa ka ng panibagong orbital gaya ng P, which is higher in energy, okay, para mag-add ka lang ng electron, that requires energy. Again, making a new orbital requires energy. That's why less energy is being released. Kaya, greater ang electron affinity ng group 1 elements and group 2 elements. I hope that's clear. So, next, higher electron affinity of period 3 elements and period 2 elements. So, that's in terms of non-metals in period 2 and period 3. So, let's compare. So, from period 2, si oxygen. Sa period 3, si sulfur. Okay. Now, si period 2 oxygen, ang kanyang electron config right is helium, 2s2, 2p4. Si sulfur naman is what? Neon, 3s2, 3p4. Now, kay oxygen guys, stronger yung electron-electron repulsions kasi mas maliit yung energy level niya, mas maliit yung orbitals niya guys, 2p lang, hanggang 2p lang. Kaya, mas mahirap na magtanggap ng more electrons. Whereas for period 3, such as sulfur, larger siya than oxygen, right? Because its n is equal to 3. So, mas may space si sulfur para tumanggap ng more electrons. That's why, higher ang electron affinity ng period 3 elements than period 2 elements. Lastly, higher electron affinity of group 2 elements than a group. So as n increases down the group, the energy gap between the filled ns2 and empty np orbital decreases, making it easier for group 2 elements to accept electrons into the np orbital. So for example, we have beryllium, so yung valence orbital niya is 2s2. Si barium naman, 6s2. So let's compare. Yung distance between the 2s orbital of beryllium and the 2p orbital of beryllium, malaki pa yung energy gap niyan. That's why it's harder to accept an electron para kay beryllium kasi sobrang taas ng energy difference between these two orbitals. Pero kay barium naman, okay, so 6s, 6p, mas madaling magtanggap ng electrons kasi mas maliit na ang energy gap nila. Okay, again, they have a smaller energy difference, yung dalawang orbitals na yan. Kaya, it can easily accept electrons. Okay, I hope that's clear, guys. Lastly, these are the exceptions for electronegativity trend. First, for noble gases, okay, we know that it has a complete and filled valence shell. Thus, they do not usually attract electrons. Okay. Second, so the lanthanides and actinides, they exhibit more complex behavior. Sila yung sa baba ng periodic table, right? Due to their f orbital electrons, causing them to deviate from the general electronegativity trend. And lastly, transition metals show a small difference in electronegativity. Okay, because their metallic properties affect their ability to attract electrons compared to other metals. Okay, so that's what makes transition metals unique. Okay. Guys, hindi ko na-expect na memorize ito agad, pero as soon as now, dapat absorb na natin yung concepts na to, okay? Because lumabas to sa board exam namin nung time natin. Siguro mga 1 or 2 items, okay? Alright, but don't worry guys, sa practice test natin, sa mock exam, eval exam, don't you worry dahil you will encounter these types of topics, okay? Ayan, so malapit na tayo matapos sa ating atomic properties na crash course video. Now, let's proceed to our Chloe cards, okay? Bagong pamasko. So let's answer. It measures the net nuclear charge being experienced by the outermost electron. Ano guys? Yes, it's the effective nuclear charge. Oh, sagot kayo with me ha? It is measured through the internuclear distance between atoms. Yes, it's atomic radius. It is the energy required to remove an electron from a gaseous atom. It increases across a period and decreases down a group. Ano yan guys? Tama, ionization energy. It refers to the amount of energy released when an electron is added to a gaseous atom. Yes, it's called electron affinity. Lastly, it explains the similar atomic radii of period 5 and period 6 elements. Ano yan? Lanthanide fraction. Yay! So we're done with Crash Course 2. Congrats guys! 2 down, 1 to go for today. Kaya pa ba? Okay guys, don't forget to take rest, okay? Huwag kayong kalimutan magpahinga. Okay? Alam kong mahirap, alam kong medyo overwhelming, but don't you worry because I'm here for you naman. Okay? So kung may any questions kayo at all, kindly message me. Okay? Now, time to answer Inorganic Chemistry Practice Test 2. So that's 10 items and you can answer it for 15 minutes. Go guys! And again, thank you ulit. So later on,